Good morning. I'll wait a little longer before we actually begin. Okay, well, it is 11:05. Hopefully this doesn't cut out. My computer just told me my internet connection's unstable. That would suck. Okay, so before we begin, I want to say again, like I said on Monday, I miss actually being at school and I miss seeing you guys. This whole thing kind of sucks and really sucks for your senior year that you're missing a lot. I will go over some key things from the humongous review and answer any questions you have from the limits review or the journey through calc. And yeah, any of these sessions on Wednesdays and Fridays are meant to be just going over the assignments that I have already been giving you and answering any questions that you have over the assignments that you have hopefully been doing. Okay. So first, yeah, Ryan asked, do we just put the answers on the Word? Yeah, if you can just type the answers onto the Word document, then just return a new file back in. Just the final answers. Just turn something in to prove that you've been working. As I said yesterday, I did put the keys up online. But if all you're doing is copying the keys and then turning those back in, I guess that would be sufficient for those of you not taking the AP exam, but for those of you who are taking the AP exam, which is the vast majority of you, you should actually do the work and then just use the keys to check yourself. Because I know we're not together in this time, but if we actually, whether we were actually in class or in this scenario, you will do as well on the AP exam as much as you prepare for it. If you don't prepare, then you won't be ready. And there's many other ways other than just what I have been assigning for you to prepare. Yeah, Peyton asked if you can send a picture. Yeah, pictures are perfectly fine. I mean, if you practice doing it that way, that's how you'll do it on the AP exam this year, or at least how you can do it on the AP exam this year. Just writing your work down and then submitting a picture. So,
where do we turn it in?
Okay. One thing I want to go over. Let's show this. We started going over this last Wednesday. If you are not yet in the Google Classroom, which is only a now very small few of you, again, the Google Classroom code is A06QSPJ. So if you are not in that yet, you need to join that. So now let's go look at the Google Classroom. At the Google Classroom, there are multiple assignments. By the way, I moved your humongous review due date to next week. Just give you a little more time on that since it's so long. I'll answer any questions you have from limits review and journey through calc today. Then I already put in next week's assignment. So that's just one assignment for next week. Those free response questions that we would have done in class if we were actually meeting, but we're not. And then something I have posted and talked about several times by now, but I want to reiterate how important and helpful it is. The AP live review videos are extremely helpful. So I've posted the link to it several times, but In this April 6th one, I posted the link to the playlist that takes you here. When they first started this, they were going over Unit 7 because a lot of schools hadn't covered differential equations yet. And they covered just a few topics of Unit 8, specifically tying them to previous topics, like only the topics that would relate to previous topics. Then Monday, they started doing actual review. AP Unit 1 limits review, AP Unit 2 derivatives review, and then they'll continue on every day at 1. These are very helpful. And if we go, and then at all of these, they have a lot of really good resources. You can just click the show more there. Then access to the lesson handouts, click on that. These are then folders of all of their resources from every one of their videos, which are all very helpful. This is the calendar of all the lessons they're going to do, which should be very helpful. The two people doing these videos have graded the AP exam many years. They're where I get some of my info and worksheets and all of the circuits, actually. So they know what they're talking about. So just to remind you how helpful these videos are. Okay, let's go back to the humongous review sheet. Okay, we went over some of Unit 1 last week. I will post the actual completed key to this. Not sure when yet, but it will get posted. Let's start looking at Unit 2. We did these 4 last week already. And so we're going to start with, what does it mean for a derivative to exist, and the idea of differentiability? Well, it's easier to understand what does it mean for a derivative to not exist. So derivatives don't always exist, and we're going to look at the times when it does not exist. So 3 ways a derivative does not exist. So number 1, first way it wouldn't exist is if it is not continuous. Second way a derivative may not exist, it is if you have a vertical tangent line at that point. And the third way is if you have a corner, can't spell, cusp or sharp turn. Because if you have a corner, cusp, or sharp turn, that's another way a derivative may not exist. So therefore, if we look at number 7 and 8, 7 says, does differentiability imply continuity? Well, based on what we said on 5, what would be the answer to that number 7? Feel free, if I ask questions, to unmute yourself and answer. That is perfectly fine. So since a function, if it's not continuous, it will not, the derivative would not exist. that would mean the only way for a derivative to exist is that if it is continuous. So does differentiability imply continuity? Yes. Every point on this graph is differentiable, so every point is therefore also continuous. But number 8 asks, does continuity imply differentiability? What if we had a picture like that? Is it differentiable at this point right there? No. That point is not differentiable. Or right here we have a vertical tangent line, so not differentiable there either. So continuity does not imply differentiability, because in both these pictures it's continuous the whole time, but it's not differentiable at that vertical tangent, it's not differentiable at that cusp. Okay, number 9, power rule, product rule, and quotient rule. So power rule, we want to take the derivative of x to the n power. I don't know why I wrote another n. That should be an equal sign. There we go. 2 more people are wanting to join. 1 second. There we go. Okay, so power rule, derivative x to the n power, as we should know by now. Power comes down, so it would be n times x. And what happens to the new power? It goes down 1 to the n minus 1 power. So therefore, if we had x to the 5th, that would then become 5x to the 4th, as we should all know by now. Then product rule. Of u times v. Okay. So that will be u prime times v plus v prime times u. And then quotient rule. dx of u over v. If you need to sing the song to yourself, feel free to. That might help. No one to laugh at you now that you're taking the exam by yourself in your own room with your own computer. So low d high minus high d low all over low low. So that would be low d high. So v times u prime minus high d low all over low squared d squared. And that's quotient rule. Okay. And then 11 and 12, I don't know why when I printed mine, the tables didn't show up. So I just had to completely rewrite the whole table. But we are finding the derivative of a to the x, derivative ln of x, and derivative square root of x. They should have also included e to the x. So I'm adding that into this table, and you should as well, although it's a pretty easy one to remember. So derivative of a to the x power. Well, that is itself a to the x power times natural log of the base, the natural log of a. Derivative of natural log of x is 1 over x. Derivative of square root of x. Well, square root of x is x to the 1/2 power. So we just apply power rule to that. 1/2 comes down, and the power goes down 1 to a negative 1/2. If the power goes to a negative 1/2, negative is going to put it in the denominator. 1/2 is still going to be a square root. So now we have square root of x also in the denominator. So 1 over 2 root x is derivative of square root of x. And then derivative of e to the x is e to the x. Derivative of sine, cosine of x. Derivative of cosine, negative sine. Derivative of tangent, secant squared of x. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant x, tangent x. Derivative of cotangent x is negative cosecant squared x. And you should also have all of these somewhere else as well. You shouldn't have needed me right now to tell you what these ones were. Don't forget, this year's test is a open notes, open book kind of test, AP exam. So if you should definitely find all your notes from throughout the year, and that would help you a lot. So let's go to units 3 and 4 now. Units 3 and 4. So, unit 3, differentiation. Still talking about differentiation now. Composite function, implicit, and inverse functions. By composite functions, we may take a derivative of a function inside of a function, which requires chain rule. Well, formal chain rule would say that if we're taking the derivative of f of g of x, that would give f prime of g of x times g prime of x. So the derivative of the outside with the inside left alone times the derivative of the inside. So if we did that here for this one, sine of x cubed, taking the derivative of that, f prime of x would be, well, derivative of the outside, well, derivative of the sine is cosine, so that'd be cosine of the inside's left alone, and times derivative of the inside, which would be 3x squared. Or on that one. Move that over. There we go. So derivative of the outside. Well, the outside function here is the parentheses getting raised to the 4th power. The inside function is what's inside the parentheses. So that's one helpful thing for any composite function. Whatever's inside the parentheses is most likely your inside function. If you have multiple functions, or if you don't have parentheses and maybe something should have parentheses, always add those in to help you see what is the inside and what is the outside function. So the 4 would, no, let me write f prime of x. It's clear. So 4 would come down, parentheses, inside function stays the same. That powers now to a 3, and multiplied by derivative of the inside. Derivative of the inside is 2x. Okay. Number 2 asks about implicit differentiation. Implicit differentiation, we're asked, how do we know when to apply it? Well, implicit differentiation generally would be when we want to take the derivative of a function where you have x and y's on the same side of the equation. We're taking the derivative and we have x and y's on the same side, and it's hard to separate them to still be a function. As well as anytime you're doing a related rates problem, that also requires implicit differentiation, specifically with respect to time. So here I have this rather easy one, x squared plus y squared equals 25. We want to find the derivative, meaning dy dx. We want to know so we're going to take just the derivative of every term with respect to what? X. With respect to y. No, x. That was dumb. So derivative of x squared. Well, that would just be 2x, and plus derivative of y squared. Well, that will be 2y times the derivative of y, which is dy dx, and equals derivative of 25. Well, 25 is a number. Derivative of a number is 0. And then next, we would just get the derivative by itself. To get dy dx by itself, we'd subtract 2x from both sides, then divide by 2y. And you would end up getting dy dx equals negative x over y, which is the slope of any point on that circle. So the key extra thing here is that whenever we take the derivative of a term that has y, we have to essentially apply chain rule, because that is a function inside of a function, because y is a function of x. So we had to also multiply by the derivative of y. Okay, now these two different charts, well, this chart right here is same chart on the previous side, but now chain rule is involved. It's a function of x. So derivative of a to the f of x power, not just a to the x. Well, same idea as before, we just also have to apply chain rule, multiply by the derivative of the inside. So it will be a to the f of x times natural log of a. But now, because of chain rule, I also have to multiply by f prime of x. Similar idea here, but when we learned this one for natural log, we used one consistent rule the whole time and just called it u prime over u, u prime over u. When it's written like this, essentially that f of x is u, so we're doing f prime of x over f of x. Then derivative square root of x. Well, we said earlier that the derivative of just square root of x was 1 over 2 root x. Well, instead of an x, we have an f of x here, so that's going to be in the same spot. And then because of chain rule, we have to multiply by the derivative of the inside, meaning times derivative of f. So now that top one is going to get multiplied by f prime. So we have f prime of x over 2 square root of f of x. And then derivative e to the f of x power. Well, that would be e to the f of x power again, and then times the derivative of the power. Okay, here we're asked, write the formula for derivative of the inverse of the function. So, given that f of x and g of x are inverses, we like to use that. G of x is easier to use than the f inverse notation. Okay. So f and g are inverses. Then the derivative of g, which is the inverse of f, will equal 1 over f prime of g of x. That's the same formula I gave you back when we did this. But I should say prime of x there. Then all the inverse trig ones. Well, sine inverse. Again, you should have these written down somewhere already. Sine inverse is 1 over square root of 1 minus x squared. Always remember, if there's something else inside of there other than just an x, then chain rule would be involved and the derivative of the inside would get multiplied. Okay, only difference between sine and cosine is cosine is going to be negative of the sine inverse. So negative 1 over square root of 1 minus x squared. Tangent inverse, 1 over 1 plus x squared. I'm going to skip those two real quick. Cotangent inverse. Well, cotangent, that just adds the co on top of the tangent. So it's just going to be negative of the tangent. So negative 1 over 1 plus x squared. Secant and cosecant, highly unlikely you will see that. Hasn't been on an AP exam in like 30 years. But it's on here, so let's write it down. Secant inverse 1 over I should have square root of x squared minus 1, then an x in front. And cosecant just has a negative of that. Higher order derivatives, well, that's just talking about taking a second derivative, third derivative, fourth derivative, and so on. And so the second derivative would just have 2 primes like that, which could also be called y double prime. Or sometimes you may also see the notation d squared y over x squared. That's all notation for second derivative. Or there's third derivative f triple prime of x, which would then have 3's right there. Or if you go higher than a third derivative, then they will put a number up there. I'll just call it the nth derivative of x. Okay, let's talk about Unit 4. Some of the contextual applications of differentiation. Okay, particle motion. Well, when you're talking about displacement, one way to think about displacement, so here they told us to use a position function s of t. Well, displacement is just the change in the position over the time. Meaning, if our time is from A to B, that would just be s of B minus s of A. The position at the end minus the position at the beginning. B, S for velocity at time 1. Well, velocity in general is the derivative of position. So velocity at time t sub 1 would then be s prime of t sub 1. Speed is the magnitude or absolute value of velocity. So it would just be the absolute value of velocity of t1. Then acceleration. Well, acceleration in general is the derivative of velocity, which would therefore be the second derivative of position. So acceleration at t sub 1 would be v prime of t sub 1 or s double prime of t sub 1. Okay. Number 2 asks how we recognize a related rates problem. Well, generally, there will be multiple rates involved in the problem to be a related rates problem. They would mention one rate and possibly ask for another rate. Generally, it will be used with shapes like circles or volume of a cone, or volume of a funnel, or a cylinder, or sphere, or something like that, or change in a sides of a triangle. But generally, it will be involving multiple rates. And general steps to solve that. Well, number 1, need a pick. You will need a picture. Almost all related bridge problems involve geometry. Number 2, you need an equation relating variables. 3, differentiate implicitly with respect to time. And what I mean by that is, if I was to pull up the same equation you did on number 2 towards the top, we have x squared plus y squared equals 25, which is a long circle of radius 25. Well, if we want to take the derivative of this implicitly with respect to time, then when I take the derivative of the first term, that will again become 2x. But this time, since we're taking derivative with respect to time, every variable is a function of time. X is a function of time and y is a function of time. So it will become 2x times dx dt plus 2y dy times dy dt, then equals 0. Then your next steps would be to plug in given info and solve. So in a problem like this, they would give you all but one of these things. Find the rate of y with respect to time, or the rate of x with respect to time, and then they ask what's the rate of the other one at a certain point. So you'd plug that point in, you'd plug the rate in that they told you, and then solve for the other one. So they would have given you all the things. You plug in your values after you take the derivative. Plug in your values after. Number 3 says 4 related rates problems. What formulas from geometry do you need to remember? You need to remember Pythagorean theorem, area of circle, circumference. All 3 of those. Prime area of triangle. Essentially, any 3D formula they will give you. Any 3D formula they will give you. You need to remember common 2-dimensional formulas. Common 2-dimensional formulas you need to remember. Okay. Number 4 asks, approximate the value of a function at a point using a tangent line. Okay, tangent line approximations. Well, first, let's remind ourselves of what the formula for a tangent line is. That would be y minus the y value at the point. The y value at the point would be f of a equals, well, next the slope at the point, so f prime of a times x minus the x value at the point, so a. So that's the equation for a tangent line in general. If we want it equal to y, we just throw that f of a over the other side, so y equals f of a plus f prime of a times x minus a. And now let's do it for this. We're asked f for this function, x squared plus x, approximate f of 1.2. So we need to know, well, to approximate, we want to pick a nice easy point near 1.2. So we'll pick when x is 1. So when x is 1, what is f of 1? Well, f of 1 here is nicely going to be 2. We need f prime of x. That is going to be 2x plus 1. So then f prime of 1 is 3. Now we can write the equation. So then the equation would be y equals f of a, so that'd be the 2, plus f prime of a, which would be 3, times x minus a is 1. Now we want to approximate f of 1.2. So this is a tangent line right here. This is a tangent line to the function x squared plus x through the point 1, 2. So that would be really close to this point. So now we're just going to plug the 1.2 in. So y of 1.2 would be 2 plus 3 times 1.2 minus 1. Well, 1.2 minus 1 is just 0.2. 0.2 times 3 would be 0.6 plus 2, 2.6. Okay, one other thing they might ask on a question about linear approximation is whether it's an overestimate or underestimate. An overestimate or underestimate. Let's remind us how to tell that. Well, if we are concave up, the entire tangent line will be below the curve, causing it to be an underestimate. Concave up, underestimate. Or if we're concave down, it would be an overestimate. So in this one, it was an underestimate. Okay, and the last thing from the review I'm going to do today, and then I'll answer any questions from the limit review and through the journey through calc. Number 5, L'Hopital's rule. L'Hopital's rule says that if limit as x approaches a of f of x over g of x equals 0 over 0 or infinity over infinity, then limit as x approaches a of f of x over g of x equals limit as x approaches a of f prime of x over g prime of x. So if it is indeterminate when taking the limit, giving you 0 of 0 or infinity over infinity, then that doesn't mean you're done right there. You can still find the limit by taking the derivative of the top and bottom individually, and then retrying to take the limit. So if we do that with these two examples I made up, limit as x approaches 0 sine of x over x, well, if we plugged in 0 on top and bottom, we would get 0 over 0. That goes to 0. That goes to 0. So let's apply L'Hopital's rule. Limit as x goes to 0 of what is derivative sine? Well, that is cosine of x. Derivative x is 1. So limit as x approaches 0 of cosine over 1. Well, cosine of 0 is 1, so that would just be 1. Then limit as x approaches 2 of x squared minus 4 over 2. Well, if we plug in 2 to the top and bottom, it does give 2. I'm sorry, that was dumb. It gives 0. So apply L'Hopital's rule. So limit as x approaches 2 of derivative of the top is 2x go to the bottom is 1. Now plug in 2, we get 4. And that's L'Hopital's rule. L'Hopital's rule is practically guaranteed for the AP exam. Like if you're going to see something involving limits, it's most likely either going to be continuity or L'Hopital's rule. Maybe both of those will be involved somehow in the test. Because L'Hopital's rule essentially assesses both derivatives and limits at the same time. So if you see a limit problem, L'Hopital's rule is probably going to be involved. That way they can assess multiple concepts at once. Okay, so we went over some of units 2, 3, and 4 from the Humongous Review. I will go over some of units, I'll go over units 5 and 6 on Friday from the Humongous Limits Review. Right now, I'll take any questions you have from the Limits Review or the Journey Through Calc. Any questions you have from the Limits Review or the Journey Through Calc? If you have a question on the Journey Through Calc, please say the question letter so I know which question that is. And again, anytime I'm sharing my screen, I think I've mentioned this before, I can't see the chat window when I'm sharing my screen because it's just showing exactly what you're seeing in my screen. Okay, 27B on the limits, you can do that, and 9C on limits. Okay, let's look at that. 27B and 9C. Okay, I'm going to share my screen. So first, 9C. So one thing we want to keep in mind on problems like this is you want to take the limit from the left and the limit from the right. If we were to just plug the x plus 1 in, that would end up being g of 1 plus 2, which is g of 3, and then plus f of 1. Well, f of 1, well, that limit does not. The limit as x approaches 1 for f does not exist, because from the left it's something, and from the right it's something else. And the limit as x approaches 1 of g of x plus 2, well, that also does not exist. But we can still figure out, or at least look a little closer at what's happening here by looking at the left-hand limit and the right-hand limit. Let's see, it'll let me draw. Move that over. Okay, so that means we want to take the limit as x approaches 1 on the left of that whole thing of g of x plus 2 plus f of x. And if we look at the left, so then that's looking at the limit as x approaches 1 on the left of g of x plus 2, which would mean limit as x approaches, as x is getting close to 3 for g. On the left, that is 3. We're just looking at the left here. Then plus, for the left on f as x approaches 1 is 1. That should be an equal sign. There we go. Equal sign. That's then 4. Then if we also look at the limit from the right, the limit as x approaches 1 on the right of g of x plus 2 plus f of x. Now we're just looking at as we approach the right, meaning as for g, as we approach the right side of g of 1 plus 2, which will give us 2. And on f, as we are approaching from the right of f of 1, which will give us 2, that is 4. And since those are the same thing, then the limit, overall limit of what they're asking about is also 4. So that is 9c. So anytime you have ones like all of 9, you would need to follow this process. 9a, 9b, and 9c need to follow this process. Because it may look like it doesn't exist. But if you have a limit of composite functions and the limit from the left does equal the limit from the right still, then that overall limit will still exist. Okay, then I was also asked about 27. 22, 13, 14, 15, 26, 27. Okay, on 27. So for 27, if we forget that we know derivatives, limit is h approaches 0. I mean, knowing derivatives, this is the definition of derivative for the function x squared minus 3x, which we should know is going to be 2x minus 3. But using limit notation, well, let's expand this. X plus h squared is really x squared plus 2xh plus h squared. Then we have minus 3x minus 3h minus x squared plus 3x all over h. Now let's cancel anything that could cancel. Well, to do that, I'm going to change colors real quick so you can really see what's happening. Let's go to green. Oops, that moved the paper. Here we go. So positive 3x cancels with the negative 3x. Okay, and this h in the denominator can cancel with one h in each term in the numerator, meaning the h in the denominator can cancel with that h right there, and it can cancel with the squared part of that h, and it can cancel with that h right there. Oh, we have something else can cancel. The positive x squared can cancel with the negative x squared. So then now this leaves limit as x, no, not x, h, as h approaches 0 of, okay, we still had that 2x there. And we still had that 1h. Was there anything left over? Oh, and then we still had that minus 3. There we go. That's what was left over. Now, limit as h approaches 0 of this is just going to leave 2x minus 3. But as already stated, we should also be able to recognize this as definition of derivative. such that this entire section right here can be considered f of x plus h. This section right here is just the f of x. The limit is h equals 0 of f of x plus h minus f of x all over h. That equals f prime of x. Definition of derivative. Well, if we can recognize that, then we just need to recognize our function and then just take its derivative. The derivative of x squared minus 3x is 2x minus 3. Okay. Okay, and then the journey through calc question H. Journey through calc question H. Oh yeah, Gia, you could also use L'Hopital's rule on that one. L'Hopital's rule would have also worked. Let me look and see what is question H. Oh, I don't want to just show the key. Here, let's look at this one. Okay. We are asked to do a right Riemann sum with 4 subintervals. Let me share my screen for this. Oh, you want G? Question G? So Gia, do you want G or V or H? Which question? V, okay. We can go over V. G double prime of 2. 1 second. Okay, so V asks, let me show the other one. Move this to the other side. V asks us to estimate G double prime of 2 and to show the calculations that lead to that answer. Almost always, whenever we will ask to estimate, oh no, that's his triple prime, G triple prime of 2. If we want to estimate a derivative, it says estimate. Well, there's multiple different options. We could estimate a derivative using just average rate of change, using really close points, average rate of change, where the derivative point is in the middle. We could estimate, and that's the most common way that you would be asked to do that or need to do that. For instance, we want to look at G's expression. So G, notice they gave us G double prime. They gave us G double prime, and we are asked to estimate G triple prime of 2. We're asked to estimate G triple prime of 2. So we're going to use the closest points we have on either side. Oh, sorry, negative 2. the closest points we have on either side of x equals -2 to be able to estimate that derivative. So again, average rate of change I know you can't see what I was just writing, but I'll show in just a second. In general, will be just slope. It's just slope. Average rate of change is just slope. So we're going to use the closest points on either side of x equals -2 to come up with the slope is around x equals -2. Well, the closest points we have on either side of x equals -2 are the first points at the top of the table. So we have x, they give us -4, -1, 13, and 10. So this is what we're asked on V. To estimate G triple prime of 2, they give us a table for G double prime of 2. And average rate of change in general would be F of B minus F of A over B minus A. Just slope. The change in the y values over the change in the x values. So we're going to use the ones close to x equals negative. I should say -2. That's what we were asked about. Oops, there we go. The ones on either side of -2. So the later one, so that will end up being 10 minus 13 over -1 minus -4. Well, 10 minus 13, that would give us -3. -1 minus -4, well, minus a negative is really plus. So we have -1 plus 4, which is a +3. So -1 is an estimation for what G triple prime of -2 is. Okay. Has to go through L. Okay, so let's look and see what was L. After this L will be the last one. It's been about an hour. L. Okay. On L, we are asked to find, well, we're told M of x equals F prime of x times G prime of x over 2. And we are asked to find M prime of 6. Okay, well, shouldn't be too bad. We'll need to use information about F, F prime, F double prime, G prime, and G double prime, all of that, which they gave us up at the top. But also, this is a product of two things. We want M prime of 6. We're taking the derivative of this M, and then we'll plug 6 in. Well, the derivative of this, we're going to have to use product rule. We'll have to use product rule. So let me go through that. Let's first just find M prime of x. We'll derive the first will be F double prime of x times the second function is G prime of x over 2. Then plus the first function is F prime of x times the derivative of the second function. We'll derive the second function. We'll take the derivative of the outside, so going to make it G double prime of x over 2. Inside gets left alone. Then we multiply by the derivative of the inside. Well, derivative of x over 2 is 1/2. So then we've got a 1/2 in front. Now we just want to plug in 2 because we're asked for, 6 because we want M prime of 6. So M prime of 6, that'll be F double prime of 6. Then G prime of, well, 6 over 2 is 3 plus 1/2 F prime of 6 G. Oh, this should have been, yeah, this is G double prime of 3. Now we just need to figure out what all of these values are. Let's go back. G prime of 3, G double prime of 3. So for G double prime of 3, they already gave us that. That's -1 right here. For F prime of 6, well, this graph is the F prime function. This graph is the F prime function, so just F prime of 6 would be that 2. Then F double prime of 6 would be, oh, that's nice. Okay, well, F double prime of 6 would be the slope of F when X is 6. Well, what's the slope here of F when X is 6? Well, that's a horizontal line. So the slope of F when X is 6 is 0. So the fact that we don't know G prime of 3 doesn't affect anything. So F double prime of 6 is the derivative of this at X equals 6. So that'd be 0. So we would end up with 0 times question mark plus 1/2 times F prime of 6. Well, F prime of 6 is that 2 times G double prime of 3 is that -1 over there. So if I go back to what I was writing, this is what we have right here for this. Well, F double prime of 6 is, as we just said, 0. We don't know what G prime of 3 is, but that doesn't affect anything since, well, 0 times whatever is still going to be 0. And we have 1/2 times 2 times -1. 1/2 times 2 is 1. 1 times -1, -1. Okay. So it has been a while, an hour-ish now, so I don't want to take up too much of your time. This is long enough. But if you have any other questions about any of the problems, feel free to email me or Remind or the Google Classroom, whatever. But the keys for both of these, limits review and through the calc, are both online. Again, I suggest watching those YouTube videos I showed earlier. And I already put up next week's assignment. So you can get started on that early if you want to. And this has been recorded, and I will also post it on the calendar. Okay, well, bye. Have a great day. Shay, I like your picture of Rick and Morty.
What's up, Mr. Hunter?
Hey, Mason.
How are you?
I'm good.
Hi, Mr. Hunter.
Hi, Bella.
She doesn't get this whole social distancing thing.
No, y'all aren't very good at social distancing.
We're trying our best.
So we got to turn all 3 of these things in by Friday?
No, Mason. The Human Genetics Review is next Friday, and the other 2, you just have to show that you are working on it. Don't copy the answer key that he posted.
Is that true?
Did I do a good job?
Well, yeah, I'm not. You have the answer key, so it shouldn't be hard to get it right. I responded to some other people this week that feel free to work at your own pace. I realized people were taking longer on the humongous review sheet, so I pushed that due date back to next week. But on the 2 worksheets I was going over today, show that you did something. Upload something to prove that you worked this week.
I have a question, Mr. Hunter.
Yeah.
So some of my homework for stats is this 2008 free response release questions of the AP exam. Is the 2008 free response questions released already?
Every free response question for AP exams have been released.
Okay.
So
AP Central? Is that where I find them?
You could find it there, but a quicker way, because a quicker way would just be to Google it. Like Google very specifically 2008 AP Statistics FRQ, and it'll automatically show up. You might even be able to find the scoring guidelines with the key.
There's no way he's grading everyone's.
Oh no, he's not. And which is, I mean, I'm not going to perfectly grade all the stuff you do over the next few weeks anyways. That's why I started this whole session with the fact that you're going to do as well on the AP exam as you put into it. I can't help you as much as I would like in this scenario. So that's why you're going to get keys to all the assignments well in advance as well, because that way you can make sure and prepare as much as possible.
Got it.
Very cool. You been doing good, Mr. Hunter?
Yeah.
Staying busy?
Enough. I have to finish my grad school paper over the next few weeks as well.
Oh, okay.
I will be done with grad school.
Dude,
That's
congrats.
crazy.
That's awesome, man.
So I'm working on that in my free time.
That's big stuff.
Yeah.
And just like you, I've also still been seeing my girlfriend. So
hey, very cool. Yeah, we'll keep that on the download. Don't want anybody finding out about the social distancing.
Yeah, although this is recorded, so they'll hear that.
Shoot. Oh, what? Oh, man. I forgot all this is recorded.
Yeah. I'm required to record every meeting now.
Very good. We've been running through the Marvel movies. We're on Avengers now.
The first one.
Yeah. So
that's a great one.
It's funny because it was the first time I like ran through it since like Endgame, and like now it's like I see in like all these movies how much they were like in advance, like just like stuff in Captain America that plays into like an Endgame, and I'm like, this crazy.
Oh yeah, Kevin Feige is a genius.
Yeah, it's it's insane.
There should have been an award for that, putting together a multiverse of
for real
mini movie stories.
Absolutely insane.
Yeah, and then he made me watch Endgame before I watched any of them.
I didn't make you.
Yes,
you wanted to watch Endgame, but yeah.
So now I already know everything.
You forgot a lot.
I did.
So.
But it's been going pretty good.
Yeah.
That's good.
All right, Mr. Hunter.
You're not gonna be the last one on?
Yeah. What, Jonathan? Get out of here. I'm always the last one.
Bye, guys.
All right.
Bye.
See you.